So we're given the graph of the derivative of g. So we're looking at the derivative graph, not looking at the original. It says, which of the following is true about g? Okay, so part A asks, if g is increasing for x is greater than 2 only. So let's look at x is greater than 2. So in order for, since we're looking at the derivative, if you look at the graph, that means that from negative 2 to 4, my slopes are positives. So here my slopes are positive. From negative 4 to 2, my slopes are negatives. So what that means is that since this is the derivative, from negative 2 to 4, my original function is increasing. From negative 4 to 2, my original function is decreasing. Since the slopes have to be positive, my original function has to look like this. Since the slopes are negative, my original function looks like that. So when it says it's g increasing at x greater than 2 only, that is true. It is only increasing when it's greater than 2. Number 2 says the function has 4 points of non-differentiability. So that means that g has 4 points where the derivative does not exist. Well, if you notice, there's a point for every single value from 4 to 4. The corners, so notice I have 4 corners, so they're trying to trick you. 1, 2, 3, 4. And we talked about how the corners, in the corners, the derivative does not exist. But because we're looking at the derivative already, the derivative exists everywhere. Okay, so the derivative exists anywhere. The one that would be true in this case would be that the second derivative does not exist in 4 places. Okay, so the second derivative does not have a derivative in 4 places. So in this case, 2 is wrong because it does have a derivative. The last one says g is not continuous function. Well, notice that it has a derivative everywhere. And remember, there was a theorem that said if a function is derivative everywhere, then it's always continuous. So 3 is wrong. So the only one that's correct is 1.